Now we have to create the tags. So creating the tags is the very easiest part in the SCADA screen. So let's see, initially we have to create the tags for the outputs. Okay, so in our PLC logics, outputs start from 0:0/0, and if you see this screen, we have total 7 outputs, total 8 outputs. So it will go up to 0:0/0 to 0:0/7. So we have to create 8 tags in our SCADA screen. So starting with, you can go to the tags, you go to new tag, OPC tag, and in the OPC section you will select your server, and the first time I'm naming it as O:0/0. So this is how I can actually memorize what I'm creating. O:0/0. Selecting the server, then you can select your device. In Micrologics 1400, this is the O:0/0 first tag. Apply and OK. Okay, similar way, this will be int 2. Maybe I cannot name that. I'll write output 0. That was the invalid name. Apply and OK. So this is my output 0. Similar way, I can create output 1, output 2, and output 3. So what I'm going to do is I'm going to pause this video. Once I'm done with 8 outputs, I'll resume back. Alright. Now we have created 8 output tags. You can see here output 0, output 1, output 2, and up to output 7. So output 7 tag is O:0/0/7. Alright. Now these are the output tags. Now we have to link this tag to the outputs. So output 0 is this one, feeder belt off. This will be tagged with output 0. So when I drag this tag to this multi-set indicator, you'll find this has been tagged. So this shows this indicator has been tagged. Okay, this is my output 0 and this is my output 1. So this will be dragged here. Okay, now output 2 is the loading. So this will be tagged to A. This one. Output 3 is unloading. So when you are going to program your screen, you must be aware that which output is which one in your screen. So this is very clear. Alright, now we have to, I just need to make sure the output for this conveyor and this conveyor. Now output 4 is the rotary motion of this turntable. Alright, which I think we haven't took in this turntable is C. I forgot to add that in our output. So I'll take another column just to indicate this is running. So I'll take a multi-state, or what I can do is I can just copy paste this one. Need to indicate that it is on. So this will be my C. Okay, so what I'll do is I'll just copy this B, paste it here, make it C. Yeah, C is turntable, means when you see this ITS, this is rotating with output 4. So this indication, I cannot have a simulation of this turntable, so I'm indicating that using a multi-set indicator C. Okay, so this is my output 4. Alright, now output 5, let me check the output 5. So output 5 is this conveyor, this is running, you can see that, output 5. So output 5 is this one, which means this one. Output 5, and output 6 is this one. And I don't think we have any output 7. And that's not, no, we don't have. It's only output 6, 7 is not active. So we have only output 7 is not valid, so you can delete this tag. Okay, so we have total 7 output from output 0 to output 6, which has been tagged to the devices here. Okay, to the elements here. So similar way, now we have to create the tags for input, sensor 0, 1, 2, 3 up to sensor 9. So I'm going to show you how to make it for 0, then I'll just pause the video and create all the tags for the sensor inputs. So for sensor 0, I have to go to tags, new tags, OPC tag. You can type it here, sensor 0. And in the OPC server, same ignition. From here you can select device I:0/0, this one. Click OK. Okay, apply and OK. So this is my sensor 0. I just need to tag that with this element, sensor 0, right? So I'm going to pause this video again and create all the sensor tags, and then I'll tag that to all of the sensors. So I have created all the sensor tags from sensor 0 to sensor 10. Okay, over here. So I'll just tag it with these elements. Sensor 0 goes here. Okay, Sensor 1 goes here. Oh, wait a second. So this is 1. Wait. Sensor 1 tag goes here. Okay, this will be, then sensor 2 tag goes here. Make sure you should not drag this to the label, it will create a problem. Sensor 3 tag goes to this block, sensor 4 goes to this block, and you see this block goes green. Why? Because in our ITS the sensor 4 is already on. If you see at the bottom of that, here we have sensor 4, this is already on, so that's why this shows as green here. This is the high signal, high status, we have to guess green. Okay, sensor 5 goes here, sensor 6 goes here, sensor 7 goes here, sensor 8 goes here, sensor 9 goes here, and sensor 10 goes here. So all the sensors has been tagged, all the actuators has been tagged. What is left is these buttons and these data registers. So let's take a look at the buttons. Now in ITS what we have is the buttons are tagged as, if I go to auto, you find a control panel here, these are tagged as 12, 13 and 14, I:0/12, 13 and 14. Okay, so what you can do is you can either just indicate their status by tagging at 11, 12 or 13, or if you want to control this environment using these buttons, so you have to create extra buttons and tag it here. So let's see the ladder logic first. The start button is here, I:0/12, stop button is here. So what you can do is you can take a parallel bit at the bottom of this button and create the tag and link that tag to your control panel. So let's do that. So in the PLC I'll go to offline. So let's start with the reset. Take a bit here, you can take it as B3:6 unused is 3. I'll use as 3. I'll tag it with SCADA reset. Okay, this is a reset of the SCADA B3:6/3. So I have to create its tag and I have to link that to this button over here. That I can do that. So for stop I can take, this is the stop, B3:6/4. I can use 4. Yeah, 4 is unused, so I can name it as SCADA stop. Okay, so for start I can take another bit, sorry, 6/5 SCADA start. Okay, now we have to create 3 tags of these same addresses and link that to the SCADA screen. And I have to make sure if I'm using start here, wherever I'm using I:0/12, I have to in parallel take this bit as well. So you can see that start is here and here as well. So I need to create similar bit at the bottom. So I can do copy and I can do paste. Start is here as well, because whenever I press start from the SCADA screen, it should also do the same thing when I'm pressing start from this ITS. So if I'm using I:0/12 for this ITS, I have to make sure I have to connect start button in parallel to every address of I:0/12 in the ladder logic. Okay, so I'm sure I'm using just here only. Later on we have all the bits, we don't have any stop or start here, right? So we are done. So let's create the tag here. Along with that we need to create the tag for this reset values. So this reset value we have to see at the bottom. Reset value is B3:6/2. This is the reset data. So 1 tag for this one, 3 tags for this one, 4 tags of memory bits we have to create. Okay, so again, if you can go to tags, go to new tag, OPC, you can create start. So the address was for start. First let me download this logic in the PLC as well. just going online. Let me go to manual, or let me reset that one. Okay, now the tag initially was b3 colon 6/3. So devices. So if you don't see b3 colon 6/ you can take this one. Okay, then click OK. b3 colon 3/ it was 6/3. So you have its tag at the bottom for the start. Alright, just drag it here. Now what I can do is, another important thing is, you can copy this tag and paste it here. This is a shortcut. So it was start, it is renamed to start1 automatically. You can rename that to stop. And the second tag was 4 for the stop logic. So here you can take 4 directly. Apply and OK. So this was stop. So you can tag this here. Now for reset, what we have here is, for reset is 3, stop is 4, start is 5. So my mistake, reset is 3. So here for the start is 5, start was 5, reset is 3, stop is 4. Reset is 3, so you can just copy paste again. Reset, that is 3. Reset is here. Reset is 3. Stop, let's just check again. Stop as 4 and start as 5. Reset is 3. This is 3. Stop is 4. Start is 5. Well, that's perfect. Now in the end we have another tag for reset information. That one is b3 colon 6/2. So that is 2. So in this case you can again paste it here. That is for the reset values, and that is 2. Reset values, this one is 2. Press enter. So reset values over here. So we have given tags here as well. Alright, now the only thing left is tag for these numeric data registers. So let's see total boxes delivered in our PLC program. Delivered is here N7 colon 3. So create a tag N7 colon 3 for boxes delivered. So I'll write boxes delivered N7 colon 3. So from the devices, micrologics, N7 colon 0, click 0 and make it 3. Oops, I click, my mistake. 0 boxes delivered so I'm using the word register. This is the word, there's no slash there. Okay, so boxes delivered is here. Now boxes in line, if you see the program, boxes in process line is N7 colon 4. Okay, so copy this one, just as a shortcut. Boxes in line, that was the data register 4, change it to 4. Apply, close, in line, drag it here. You can see that the status has been changed to 0. A number of small boxes and number of large boxes. Number of small boxes. Now in this case, the smaller box come if your only sensor. If I zoom it here, now this is the height. These are the height sensor. These are the 2 sensor. If sensor 1, wait, sensor 1 and 2 both are on, it means box is bigger. If only sensor 1 is on and 2 is off, it means box is smaller. So if 1 is on and 2 is off, box is smaller. We are getting the smaller results in N7 colon 5. 6 is for larger boxes. So 5 for smaller, this is for larger. So smaller is N7 colon 5. So I'll go here, create another tag N7 colon 5 small, wait, this will be 7 colon 5, this goes here, small boxes, number of large boxes goes in 7 colon 6, so I'll copy that, paste it here, this will be large boxes, this will be 6, apply and OK. So large box will come here. Now boxes delivered to this conveyor and this conveyor. Let's see its tag. Total boxes delivered has been done. Boxes delivered at left conveyor, this is N7 colon 2, at right conveyor is 7 colon 1. So you can go to tag again. I'll just paste it here. I'll write boxes left conveyor. Now left will be left from this way. This is the right, this is the left. So for left it was colon 2, 7 colon 2. This will be colon 2, apply, OK. So left conveyor will come here. For right conveyor is this one, so I'll copy that, paste it here, boxes, right conveyor, and for right conveyor this is 7 colon 1, so make it 7 colon 1, apply and close. So for right conveyor this will be here. Alright, so boxes feeded, this is left, boxes feeded, boxes fed is 7 colon 0, so I'll paste it here, boxes fed, so it's boxes fed actually. Alright, this will be tagged with 7 colon 0 like that. So I just need to correct a little mistake in my program. What I did was in the last this is same, so I need to just change it very quickly and we're going to simulate that. Oh, this is different. Okay, we are done. Now let's simulate that and see the results. So this is the logic, and I just want to show you first how this is linked to ITS. So in ITS, if I go to auto, if I press start, so you see two outputs are on, output 0 and output 1, and conveyors are running and boxes are coming. You can see the similar thing here. Feeder belt on, table on, the sensor was on before and the sensor is on. So when the box reach, now these two boxes are on. And you can see that number of boxes in line 2, number of small boxes, number of large boxes, boxes delivered is 0, and the status is coming here. This conveyor is on. The same thing is happening here. You can relate this, your plant, with your SCADA screen. This conveyor is running now, so this conveyor is on. Boxes delivered here is 1. This is the second box delivered to this conveyor. So once it is delivered, this is 2. And you can see the status of this table over here again, the sensor status. So everything what is happening here has been, you can see that you can acquire the data in your SCADA screen. This is the conveyor table, this is the table. This conveyor status is here. Alright, this is the bigger box. So if we see number of bigger boxes has been increased, 5. Just one smaller boxes so far. Boxes delivered is 4, boxes in line is 3. In line means this is 1, this is 2, and this is 3. 3 boxes in line. Okay. Now none of the box has been delivered to this position, so this is 0. So when you get the small boxes again, you will see this will be incremented. Okay. So I hope this makes sense. Now this is the belt, which status is here. Now what we are finding difficulty is boxes fed is 0 always. We need to see this data register. So let me check first. Boxes fed. And you'll also find the same information in these data registers, 7 and the 7. On the left and right conveyor is 0. So boxes fed was this one, N7 colon 0 is 11. We check the status. Boxes fed is N7 colon 0. Sorry, this is apply. Okay, so target here. Now this is 11. So this has been resolved. Now if you want to stop the operation, you can press stop. Let me go to run condition. You can press stop. Oh, this needs to be read write. So you go to read write mode and you can press stop. So after pressing stop, after current operation, boxes will not run. So everything is stop here. Okay. If I press start again, this will start running. So when I press start here, so you can see that this operation resume. So this screen is also controlling my ITS screen, and this is the reset value which will reset the values here. So if you want to start over again, if I press stop, so in stop the program is done in such a way that current loop will complete and next box will not come by stop. Now I want to clear everything. So what I can do is I can press reset here. This will turn off all the actuators, and after pressing reset I can press reset values. So by pressing reset value, this has been gone back to 0, and this is resumed because there's some logic which is overwriting the values. I need to check that. Yeah, some bit is on since the 3 is on. So you need to synchronize your logic with this SCADA screen. This is just for the demonstration. This is the reset data bit, which is clearing this data register. 4 and 3 is being overwritten. I need to check that 4 and 3 is being overwritten. Yeah, this is overwritten because there's no bit here. That's why. So if you want to again start the logic, you can do that by pressing. You can clear these values again, and you can reset the values. Now you can start the process again from here. So this will start again. So this was how you can link your values, you can link your information from your SCADA screen to the PLC ladder logic, and you can monitor your plant. Alright, there is just a few logic bugs to reset the values, which you can do by yourself by just adding some interlocking the bits and clearing the values of these data registers, which is not a big deal. What you have learned here is how to tag the values of PLC program to your SCADA screen and read your real-time plant in real-time information. Alright, so this was about how we can read box sorting information in your SCADA screen, and we'll be doing a few more projects to read a paint production, and one is to read analog values from the VFD feedbacks. Okay, I hope this makes sense and you have learned a little about how to create screens on SCADA software. If you have any doubt, you can get back to me. We'll see you very soon. Thank you.